Hey y'all, it's Miss Power. I am here with the quiz review. The quiz we're taking on Friday, December 6th, or not December, oh my gosh, September 16th. I am about to post the review to Google Classroom. I'm going to go through it right now in a video, and then I will print out the review so you can pick it up tomorrow if you want to do it for homework. Okay, number one asks to write the equation in vertex form that represents the graph, then find the vertex axis of symmetry, etc. So I give you a graph, you give me everything about it, including the equation. The very first thing I'm going to do is try to find the vertex. The vertex is always either the minimum or the maximum point. It's the one right in the center. Here's the vertex. I went over 2 and up 3, so my vertex is 2, comma 3. I'm going to do this in rainbow order. So the stuff I do first is going to be red, then orange, yellow, etc. Right? Okay. In that same breath, I'm going to say that this is a minimum because it is the smallest point in my function, the lowest down point. All right, number 2, I'm going to say axis of symmetry. That's just this line. It's always x equals a number. Here, x equals 2. So my axis of symmetry is 2. My number of intercepts, I count how many times my function crosses the x-axis. Here it crosses the x-axis 0 times, so there are no x-intercepts. 0 x-intercepts. Does it open up or down? It opens up, right? It's going up. And now I'm finally going to do my equation. I already know from my vertex that this is going to be x minus 2 squared plus 3. So my first step when I write my, actually, I tell you what, no. My first step is I know that it needs to be vertex form. So I'm going to write my pattern in like this. Then I'm going to notice that my vertex was positive 2, 3, so this should be a negative 2, positive 3. And then very last, I want to know what A I have, what vertical stretch I have. So I'm going to, from the vertex, count over 1, and then see how far up I went to hit the function. If this is also a 1, that means it's a 1 out front. If it's a 1 out front, we don't even need anything. Nothing, or you can put a 1. Either way. I'm going to go ahead and erase this because we don't actually need it. That's how I build my equation. Again, start from the pattern. The vertex form pattern is the x minus blank squared plus blank, maybe with a number up front. Plug in my vertex, and then check to see if I have a vertical stretch. So this is no vertical stretch. All right. This version, I gave you the graph, and you told me the equation. In this version, I'm going to give you the equation, and you're going to tell me the graph. So let's keep going. First, I do my vertex, always. And then I'm going to do my axis of symmetry next. My axis of symmetry is always x equals a number. This is always x equals a number. I'll put that here too. Because it's a straight up and down line, it's a vertical line, and that's x equals a number. And it's always going to be the same x value as your vertex. Let's go ahead and graph this and then answer the rest of these questions. So I'm going to graph my vertex, negative 3, comma 4. Then I'm going to fill in my, when I go over 1, how much do I go up by? Let me not do this in yellow. It's hard to read. When I go over by 1, how much do I go up by? And when I go over by 2, how much do I go up by? In the parent function, this is 1, and this is 4. But we want to multiply it by our a term. So we want to multiply this by -2, and we want to multiply this by -2 as well. So we're going to go up -2 and up -8 when our vertical stretch is -2. All right, let's plot our next 2 points. I'm going to do these 2 points in light blue and these 2 points in dark blue. My light blue points, I start at the vertex, I move over by 1, and I move quote unquote up by -2, which just means down by 2. So I started at my red vertex, I went over, left, and right, and then down 2. Next 2 points, I'm going to again start at the vertex, go over by 2, and up by -8, aka down by 8. I then very artistically draw my line, but knowing that Miss Power is about to grade me on the dots rather than the line. Now we can go back to answering questions. Is the red vertex a max or a min? It is a maximum because it is the top of our function. There are 2 x-intersects because it hits the x-axis twice. And it is opening down. I do now realize I forgot a problem on the top one. No, I didn't. It's just this one. Okay, and now I want to know the transformations. So I'm going to go in black. There are 3 transformations from the parent function. There's 3 things we did. We moved it to the left by 3. Let me actually write this in print yellow. It says left shift 3. We moved it up by 4. Up shift 4. And we flipped it. Used to be right side up, now it's upside down. Flip and stretch by -2. We used to go up, and then we kind of stretched it and flipped it in the same turn. I think there's probably 3 on the test. We probably should have called this 4, but that's how it goes. All right, what does standard form and vertex form mean? Standard form is when your function looks like this. Right, this is standard form, this ax squared plus bx plus c. We've said this a lot in class. We really haven't written notes on it. We'll write notes on it tomorrow. But examples of standard form are like 4x squared minus 10 plus 3, or even just 5x squared plus 10. If there's no b term, that's fine. It just means b is 0. Or negative x squared minus 4x. These are all standard forms, right? It's the x squareds, x's, and numbers either added or subtracted together. Where vertex form, oh gosh, the vertex form in blue, this is the ax minus h squared plus k business, right? This is the graphing form. We call it vertex form, and it's because it's easy to find the vertex. So here an example of vertex form is, I don't know, 4x minus 3 squared plus 10. Or even if there's no a term, this is still vertex form, even if there's no h. Or maybe it looks like this. Not really this one. These are all vertex form, right? It's when we something like that. This one hilariously is a funny one that we'll talk about when we get to factored form. But for right now, we can think of this as vertex form, where our k is 0. All right. Last type of question, not too long. Last type of question, complete the square to write each parabola, or to write each equation given in standard form into vertex form. then state the vertex of the parabola. So I give you standard form. That's like this red form. I want vertex form, this blue form. So on my test, I would immediately write in these blanks. Right? I know I want it to look like this. So I'm going to write this in on my answer so I know what my answer should look like. Nice. Now we get to work. Okay, I know that this part can be thought of as the beginning of a perfect square, and then this is either going to be amazingly perfect already, or we're going to have to say, we were wrong by a factor of like plus 12 or minus 6 or something like this. So what I want to do with these is write this as if it were perfect, a perfect square, by doing 18 divided by 2 squared right here. And then I want to change it so that my equation actually equals 90. That the C actually equals 90. All right, 18 divided by 2 is 9. 9 squared is 81. So this was 9 different than I actually wanted. If I had this perfect square, it would be an 81 based on the fact that it's 18x. But we've got 9 extras. We've got 9 leftovers, which is totally fine. What we do here is we change this into a plus because this was a plus. We put a 9 here. This is always the 18 divided by 2, just not squared version when there's no a. And then we say plus 9 on the back. There's no number out front in the original equation, so that there's no number out front in the final equation either. And now when I do the vertex, I do it the same as when I graph, which is I take this first number and flip it, and I take this back number and I repeat it. Here's a different way of thinking of this. If I wanted to make a perfect square here, I would do my x squared, because I've got an x squared. I've got 18 x's I want to put on this picture, so I'll put half of them down here and half of them down here. That means my square is x plus 9 times x plus 9. The dimensions are x plus 9. Which means if this were a perfect square, I would use 81 of my 90 blocks, and I would have 9 left over. And this would again also give me this equation, where this was the size of my blocks and this was my leftovers. That's another way to find this equation, if you like the pictures better rather than the equations. All right, let's do this one both ways. I'll do pictures first for this one. I've got 2x squareds, so I want to draw 2 pictures. I've got 24 x's. I have 2 blocks and 24 x's, which means I want 12 blocks to be here and 12 x's to be here. So I divided the 24 by 2 to see how many would be in each block, and then I divided it by 2 again to see how many would be on each side of the block. So I think these should be 6x each, because 24 divided by 2 is 12, and when I split 12 in 2 parts, I get 6. My length then is x plus 6 and x plus 6. Which means this should have been 36. Which means in total, I used 72 blocks But I actually only had 40. But I only had 40, which means I was missing what? 32 blocks? I think we can use everything here to fill in our equation. This is the block size. This way. This is the block size, which here is x plus 6. This is how many blocks there are. Which here is 2. And then this is how many leftovers we have, which here we had negative 32 leftover. We didn't have any leftover. We actually didn't even have enough, right? So we're going to make this a minus 32 on the back. Make this look nice. Sorry. Great. Okay, if I'm looking at the picture and I want to know the equation, the number on the outside, the A, is how many blocks we have. The number on the inside, the H, is the size of the blocks. And the number on the outside, the K, is how many leftovers or how many missing we had. And when we're missing, we go minus. We've got leftovers, we go plus. I'll do the equation way as well. And feel free to fast forward to the part that you don't care about, right? The equation way, I'm saying I've got 2 I have 2x squared, so I want to just consider the x squared version. I'm going to factor out a 2, so I can just think of the x squared version. If my x term is 12, I think that the perfect square version of this is plus 6, because it's half of 12, and I would have used 36 blocks. When I added in a 36 here, I'm technically multiplying it by 2. So these two things together mean I've added 72, because 36 times 2 is 72. However, I want the number on the back to be 40, so I need to minus 32 so that my end result is actually 40. And thus, we get the same equation twice. Afterwards, we find the vertex. That's negative 6, negative 32. Because again, we switch this number and we keep this number the same. All right, let's try it again. Same song, different verse. I'm going to do this one kind of quick. This number is 3, because it's just the A term. Right? This is A. This C, you could do it the exact same way I did B. Taking care that whenever we divide 24 in half, we got a positive number because it was positive. Here, when you divide 30 in half, you'll get a negative number because it was negative. This is always B divided by A and then also divided by 2. Where this was B. And that was still A. So here, my B divided by 2 divided by A, I have negative 30 divided by 3 divided by 2. Negative 30 divided by 3 is negative 10. Divided by 2 is negative 5. Negative 5. And then this last number is kind of a doozy. This number is C minus whatever this number was squared times A. Here's what happens, right? Let's go back to this picture. We divided this number by A to see how many blocks we were using. We then divided that number by 2 because we wanted to put it in 2 different parts. We then squared it to see what was happening here. And then we multiplied it by 2 again to see actually how many we did. We multiplied it by A, the number of blocks again, to see if we added 36 two times, we actually want to think of that as adding 72. All right, so here for our example, we've got what? 25 minus negative 30 divided by 3 divided by 2 squared times 3, which is 25 minus negative 5 squared times 3, which is 25 times 3, which is 75, which is minus 50. So I think this should be minus 50. Let me erase this plus. Boom, boom, boom. Minus 50. I'm going to challenge y'all to do this, whatever way you like best, and then check your answers against mine, right? Yeah, make sure you get the same equation. If you like, just being very systematic, memorizing equations, plugging in numbers, and chugging away, go for it. This is another good method. This is not something we talked about in class because I think a lot of people much prefer to think about it and like have something to understand rather than just memorize random symbols. But if you want to memorize random symbols, here they are. Let's do our vertex. Should be 5, negative 50. Last one. This is similar to this first one, except we're going to have fractions, right? Anytime this is an odd number, it's totally okay, but we will have fractions. Let's try it as a picture first. I think it's kind of funny to try as a picture. We've got our x squared. Nice. This should be half of 11, and this should be half of 11. So I'm going to write this as 5.5x and 5.5x. So far, I think it's pretty good, right? Now we say this is x plus 5.5. This is x plus 5.5. We already get to put plus 5.5 here. We also already get to put 1 here, or we get to erase this out front number because there's only one block. Now the only question is, what goes here? If I do 5.5 times 5.5, 5.5 times 5.5, let me get my favorite calculator out, the one I don't bring to school just in case it gets lost. 5.5 times 5.5, I get 30.25. We didn't actually have 30.25. Did we have leftovers, or did we not have enough? I think we didn't have enough, right? So if we didn't have enough, I do 3 minus 30.25. Negative 3 minus 30.25, and I put that answer here. So this is definitely going to be negative. Move this here. This is going to be negative 33.25 with a terrible, ugly, but super correct vertex of negative 5.5, comma, negative 33.25. My 5s really look like 6s today. Again, if we want to do the equation version of this, we would come over here and say x squared plus 11x. The perfect thing would be 30.25, but we would need to subtract 33.25 from that to make it actually equal negative 3. This first part would then get a perfect square, and we would subtract off how much we were deficit by on the back. Yo, that's the quiz. I'm going to give you one question that looks exactly like this, one question that looks exactly like this, one question where I give you a bunch of examples and you tell me which form it is, and then 4 exactly like this. There's going to be a super hard one for bonus, but it's a bonus, so I'm not going over it. Right? All right. Talk to me about this tomorrow, sometime during class or after class. If you are confused, give this video a watch. I'll have these printed out for homework. It's not necessary that you do it, but boy, is it helpful. All right. Good luck, y'all.